So before moving into the session, I would like to ask all the participants to turn on their camera for the photographic session. Participants are asked to turn on their camera for the photographic session. I request our resource person to turn on their camera for the photographic session.
Yeah, I'm trying, but there's a problem with the camera. It's not working. So let me log off and then log in again. Maybe it will work out.
Okay, sir. Participants are asked to turn off their cameras. I repeat again, participants are asked to turn off their camera. So before going on to the session, I would like to introduce our today's resource person. It's my pleasure to introduce our speaker, Dr. Rahul Johari. He is an associate professor at University School of Automation and Robotics, Guru Gobind Singh Indraprastha University, Delhi. Dr. Rahul Johari has more than 24 years of teaching and research experience. He has completed his Masters of Technology in Computer Science from Guru Gobind Singh Indraprastha University in 2006, and he obtained his doctorate from Delhi University in 2020 and pursued postdoctoral research at Jawaharlal Nehru University in 2022. He published more than 66 journal articles, 144 conference proceedings, and contributed 10 book chapters. He also authored 2 books and holds 3 patents. Dr. Rahul Johari is a Microsoft and Google certified professional and an ODEM certified blockchain faculty. He is currently guiding 5 PhD scholars, and one PhD scholar has already completed under his supervision. He is an active member of professional organizations like IEEE, ACM, and CCICI. He delivered more than 180 initiative talks on cloud computing, blockchain technology, Internet of Things, cryptography, and network security. Ra- Dr. Rahul Johari has also delivered invited talks at prestigious foreign universities including Cambridge University, UK, Nanyang Technological University, Singapore, Shenzhen University, China, University of Sterling, UAE, and ITMO University, Russia. For his contribution to academics and research, he has received the Outstanding Researcher Award, Best Teacher Researcher Award, and People Choice Award. We are honored to have him with us today. Without wasting the time, I would like to hand over the session to Dr. Rahul Johari. Please, sir.
Thank you so much for your nice introduction. Good evening, all. As I rightly introduced myself, Rahul Johari. Currently, I'm working as associate professor with University School of Automation and Robotics in Guru Gobind Singh Indraprastha University. So I will be sharing my slides with you, and please let me know once it is visible. Is it visible?
Yes, sir, it is visible, sir.
Thank you so much. Thank you. So I joined my university in 2007. So I've been working there for almost 15 plus years. And I have set up a research group in my university called Swinger. It's called Security Wireless IoT Network Group of Engineering and Research, wherein I try to do a good quality research work in multiple domains like security, wired and wireless network, Internet of Things, cloud computing, blockchain technology, cyber security, cyber physical system. And last year only, I started the work in metaverse, that is augmented reality and virtual reality. So there's a very good saying in education scenario, and especially in higher education, that every teacher or every professor is in need of the good students who can be a part of his or her team and do a good quality research work. Similarly, a student is always look out for a good teacher or professor who can mentor him, who can guide him. So I have been fortunate enough to get some good quality students to work with me in the last decade, and they worked under me on the BTech projects, the MTech projects, and many of them are the PhD scholars. And along with them, I have been able to publish good quality research papers, both in journals, conferences, and I have also find patents, as you rightly said, three of which have been awarded, and four of which have been in the filed or published state. So, the life of a teacher is that is what it is all about. Set up a good team, get a good members, and they will work under you, under your supervision, under your mentorship, so they can reach up to the new heights and do some good quality work in your domain. So, in what I also did, I also started internship in my research group on multiple number of topics, and we don't charge anything. It's all for the students. We I've listed multiple number of topics in my research group site, and these are all the multiple topics. And like especially today's discussion is all about the IoT. So we'll discuss about the IoT part mainly. So in the IoT, we do normally simulation regarding two simulators. Now there are two tracks in the IoT if we talk of. One is a software track, one is a hardware track. Hardware track, many of you might have been already working using Arduino and Raspberry. Now that requires a bit of expenditure, and most of the students are not ready to spend the money on purchase of the sensors, on purchase of the Arduino kits and Raspberry kits. So there are two good simulators. Like one is a cup carbon simulator. It's a very good simulator. If you are working in Java programming language, this simulator is very good. You can download the simulator free of cost and you can start working on it. And if you want to good in C programming language, if your students are good in C programming language, then they can go for the Contiki Kuja. That's another good simulator on which you can carry out a simulation. So we'll discuss these things and many more things during the discussion for the next 1 hour or so. So I'll be talking about these simulators. They are very good simulators for IoT. So depending on the problem statement I've chosen in my IoT, I can start working and download these simulators and then use them. Then there are multiple number of other areas like cloud computing, blockchain, cyber security. I work in those areas, so I've identified multiple number of internship topics on which the students can work on, and I can share with them with you if you want. You can also share the same topic with your students, and maybe if they feel interested, so it will be good for them. And we don't charge anything. That's the first thing. I always believe students are the ultimate ambassador of our teachers, so we should not be charging anything from them. Knowledge should be beyond the boundaries of cost as sudden. already they are paying good fees to the college. As a teacher, whatever we can do best to them, we should do them for that. So more than 50 topics are identified in our research group. We give training to them on the multiple topics of IoT also. So let me start the presentation. Yeah. So this is about me. My mail ID is rahul@ipu.ac.in. So if you ever want to reach out to me, please use the mail ID. I will be happy to answer your queries within a day or within 24 hours. If not the same day, maybe the next day. And this is my number. You can always WhatsApp me or text me regarding whatever we'll discuss today in our session. Now, I always start my slides with a person who has done a lot of good work in that particular domain. Like when I start with the delay tolerant network or the DTNs, we always discuss about the Kevin Fall. He did a lot of work in the delay tolerant network. Same way when we discussed about the MANETs, mobile ad hoc networks, we discuss the work of Charles Perkins because he has done a lot of good quality work, a high quality work in the particular domain of mobile ad hoc network. Same way in the case of IoT, a lot of work has been done by this particular person called Kevin Ashton, which I think multiple speakers might have discussed about in the last 2 days if you're FDP. So credit goes to him for coining the word IoT, for thinking about it for the very first time that such a network can exist because somewhere the idea has to come for the very first time. So the real credit goes to him that he came up with the idea of finding such a network wherein communication is possible when the nodes are in the overlapping transmission range of each other. And the role of sensors is very much evident in IoT. We'll also discuss about the sensors. So basically, the term, the topic, the concept, the first it ever came in the mind of a person called the Kevin Ashton, and for that he was also nominated for the ACM Turing Award. Now, since many or rather most of your faculty from the multiple domains, I think so, from computer science and ECE, in computer science we do not have a Nobel Prize. I think all of us are familiar with that. We do not have a Nobel Prize in the case of computer science. The Nobel Prize is usually given in the area of pure sciences, the physics, chemistry. That's not even in the case of mathematics because mathematics does not fall into a category of the pure sciences. It's fall in the category of arts and humanities. So in 1965, what did the ACM did? Association of Computing Machinery, the organization, they started the Turing Award in the honor of Sir Alan Turing, kind of work he has done. And every year the award is given to a person or a group of person who have done a lot of good work, good quality research work in the domain of computer science. So they started the award in 1965, and right now we are 2025. So almost 60 years have gone by, and you'll be surprised to know that out of these 60 years, only one Indian has ever got the ACM Turing Award. So that also speaks of the quality of the education, higher education we have got in India. So that in the sense, I don't want to criticize anyone, but then if we are able to get only one award in the last 60 years, means we have not been able to do a breakthrough research in the domain of computer science and IT. What we have been doing is more like a follower approach. And even the one award what we get, if you, some of you might have heard his name is Professor Raj Reddy, and he got the award in 1994 in the field of artificial intelligence when he was working for medicines and in the area of pharmaceuticals. He was trying to work out some drug research. So he that for that domain he got the Turing Award. So even Kevin Ashton never got the Turing Award, but he was one of the nominees for that particular area. So this is just like Gandhiji never got the Nobel Peace Prize, instead, in spite of doing the outstanding work for the Indian freedom scenario. Same way, there are many good people who did a good quality work, but they never got the award. They never got the recognition they deserved. So Kevin Ashton also missed out in that. But then, yes, he was shortlisted. At least due credit can be given to that in that scenario. So most of the speakers will also discuss about the IoT. So I also picked up the definition, a brief definition rather. A network of physical object, devices, vehicles, gadgets, any kind of electronic gadgets, and other items which are embedded with the electronics, software, sensors, and network connectivity, which enable these objects to collect and exchange data. So IoT today includes everything. So we have also got IOX, that stands for Internet of Everything. I- Internet of Things, IoT, and then IOX called as a uh, Internet of Everything. That is I. That includes everything, all kind of electronic devices, gadgets, mobile phones, smartphones, PCs, laptops, cameras. You name it, they have it. They include every kind of the electronic devices for that matter, which enable these objects to collect and exchange the data freely and smoothly without any problem. Now, IoT, very important places. Where do we establish the network? So there are two kind of the environment. One is a controlled, and one is a hostile. Now, control is something, a network which is usually established in our labs, in our offices, where I can control the nodes. I know what is the location of the nodes. I know what is the latitude and the longitude coordinates of the nodes. And the nodes are under my supervision, right? So everything is under my control. Or I can establish a network, in, let's say, in an open domain. For example, I have been approached by a company to set up a network comprising of multiple number of nodes in the Jaisalmer district of Rajasthan. And what is the problem statement? They want to measure the atmospheric temperature, pressure, humidity, soil condition uh, in the winter and in the summers. That means 1st to 7th of January and then 1st to 7th of June. So that is what their objective is. They want to measure atmospheric temperature, pressure, humidity, soil conditions, so that they can have a prediction about the vegetation, which kind of vegetation is best suitable to be grown. And if you know the Jaisalmer district of Rajasthan, it's very hot in summers. It's very cold in winters. So that means that is the kind of environment which is being given to me. Now I need to establish a network in a real-time scenario. So what I will do, I will identify the nodes. Now, selection of nodes, or rather, we say selection of sensors, is itself a very critical element in the entire IoT. And if you look out for the sensors in the market, there are sensors starting from just few hundreds of rupees to going to thousands of rupees. So selection of sensor play a very important role. No, I'm not advocating any company, but there is a company in Bangalore called Texas Instrument, TI. I have found the sensors of that company to be good. They are the Indian distributors of the US multinational. So I have purchased them in the lab and I have got a good experience with them. So there could be many more companies operating on Indian soil in the dealing in the sensors. So selection of sensors, specification of sensors, precision of the data being captured by those sensors is very important because if you have been working in the area of artificial intelligence, AI is all about data management, data handling, but IoT is all about the capturing of the data in the first place. So you can do the analysis of the data later on, but the first of all capturing should be in the right time, in the right place. If there is a flaw in the capturing of data, what you will do with the analysis of data? You can't do nothing. Nothing is possible, right? So we need to capture the data in a right manner, at the right place with perfection, with 100% accuracy. Because then only I can apply my supervised and the non-supervised machine learning algorithms like naive Bayes, clustering, support vector machines, decision trees, or any other kind of the algorithm to analyze the data and then make a suitable prediction. So first of all, data has to be captured in the right spirit. There should not be any flaw in the data because the entire analysis process will go wrong as such. So I say selection of sensors, the type of sensor play a very important role in the entire IoT. So this IoT is all the game of sensors. And we'll have a sensors for monitoring and measuring atmospheric temperature, pressure, humidity, seismic vibration, or for the prediction of the earthquakes, especially in those regions which are highly volatile, like Japan. We know it's highly volatile region. or will suffer by tsunami, or Indonesia for that matter, Jakarta. So there are multiple regions where sensors will play a very dynamic role. Or for I want to measure the soil condition. And most of the sensors today are unitasking. There's no sensors in the market which can do multitasking. There could be one or two sensor from the companies who operate in Malaysia or Taiwan or China or the Mongolia, because that is the real hardware of the hub of the world. But otherwise, there's always sensors are unitasking. They are designed to do one job at a time. We don't have a sensors who do multiple tasks or multiple jobs at the same point of time. We also not encourage these kind of sensors. Single tasking sensor for single task is always benefit or preferential as compared to the multitasking sensors. So market is flooded with multiple type of sensors. Like we got a color sensor. Is the slide visible? And are the slides rolling? Anyone can
So,
say please yes or no.
so slides are visible, sir.
Okay, so we can intro if this is a slide, we can see here there are different type of sensors in the market, like color sensor, gas sensor, LDR, alcohol sensor, smoke sensor, PIR sensor, rain sensor, heartbeat sensors, touch sensor, photo sensor, so soil moisture sensor, ultrasonic sensor. So point to convey here is that first of all, I need to identify what is the problem statement on which I am working. And there's a very good statement in research that identifying a good problem is itself a problem, right? So if you're looking out for a topic for your own PhD, or if you have done the PhD and if you're searching for the topic for your students, like the BTech students or the MTech students or the MCA students, you can give this to them that they can start working in the area of the IoT, because that's a good area. And in the coming years, lot of work has already been done in the past decade in the domain of IoT, and lot much work still need to be done in the domain of the IoT in the coming years. So it's a good happening field, a evolving field, a lot of work required to be done both at the hardware level as well as at the software level. So as I said just few minutes back, identification of a sensor play a very important role, because the data has to be captured in the right way. The data should not be flawed. So the characteristic of a sensor play a very important role. The name of the company which has built it, the brand, the precision value, the accuracy, the configuration, everything play a very important role whenever we deal with the sensors. Now, what should be the typical life cycle of any IoT device? So there are multiple phases that every node in the IoT network goes through. So first step involves the deployment of the node in a real-time network. For example, let's take another problem statement. Since I reside in Delhi, so the nearby hilly areas to Delhi are either I go to the Shimla in Himachal Pradesh or Manali region, or I go to the Uttarakhand district, uh, which is very close to Delhi, hardly maybe 300 or 50 kilometers away. So if I've been given a problem statement to identify again the atmosphere temperature, pressure, humidity or soil condition in the hilly regions. Now hilly region, I know it's a very turbulent, volatile region, right? The terrain is not flat. In the case of the city, the terrain is flat. The flat city roads are there. But in the case of mountainous region, it's not the case. The things are scattered, the mountains are of uneven height, so the transmission will get affected. Cannot have a line of sight transmission, that will get badly affected by the uh, cones of the mountain. So communication between the nodes in a network will be a challenge if I compare the establishment of the same network on the city or in the urban region. So hilly region will have their own challenges. So here, if I deploy the node, so management of the node is a very difficult process, because node can get damaged maybe due to the flash floods, cyclones, thunderstorm, anywhere. So whether I deploy the node in a desert region or if I deploy the node in a mountain region, every region has its own challenges. Mountain region will come up with its own problems, whereas desert region will have its own kind of high temperature will be there. High stream winds will might be flowing. A thunderstorm might come. The entire network gets blown away in the wind. So every network has its own challenges. So once I deploy the node, I need to regularly monitor the node. Monitoring means taking care of health of the node, seeing the wear and tear part. Is the node getting damaged? So you are the doctor for that particular node. You are caregiver. You need to take care of the node just like your own baby, so that the node does not get damaged. Because it's been in the open situation. You have established the node, established the network in the open domain, in the real time scenario, in the flat domain, not getting protection from the outside world. So I need to not only do a monitoring part, but I need to do a servicing part of management of my node as such, so that all the data that is captured is properly archived within the cache memory of that particular node. And later on, maybe after few hours or few minutes or few days, the same data gets relayed to the data centers set up in the same region, because we have got almost 5 kilometer network range. So our multiple data centers get established so that they can keep on capturing the data and archive for a longer duration of time, because every node will have its own limited amount of memory. But so I need to archive the data somewhere at the local data centers. So I need to establish multiple number of local data centers, and all the nodes will be connected to that local data centers and will archive or relay the data so that the data gets properly saved and secured. So and also I need to do good management of the nodes. How many number of nodes do I establish? What should be the location? What should be the position of those nodes in the IoT network? What should be the ideal position? Because I also need to go for optimization of resources. Uh, my objective should be with a minimum number of nodes, I should be able to cover maximum amount of the vast area possible in that particular node, because I have to look out for the cost of establishing the network. So I don't have that much amount of money where I can spend on establishment of nodes in the network, especially if I'm a startup company. So my funds are critical, because almost all the companies are venture capitalist supported or angel investors have put in money. So every penny is very crucial to me. I can't waste it. So I hope we understand that. So management of the nodes in a network is very critical. Then all the nodes have, I need to take care of the software and the hardware updates of that nodes. So that node remains relevant, node remains useful, and it doesn't get obsolete over a period of time. So regular periodical updates are required in the management of the nodes. And finally, once I have done my project, once I have sorted the problem of my client, I established the network for 7 days, or let's say 14 days in the desert region. I've captured the atmospheric temperature, pressure, humidity, and the values. And now I need to decommission that particular node. So after relaying the data over the cloud, that is point number 6, after I've conveyed the data has got archived properly. Now I can go and decommission that particular node in the network. That should be my objective as a project manager who is managing that particular IoT network. Now, applications of IoT, there are many applications of IoT. I think some of the speakers would have already talked about it, so we don't need to go much into detail. Just briefly touching like the smart mobility, smart grid, smart home or building, public safety and environmental monitoring, medical and healthcare, industrial processing, agriculture and breeding, independent living. So if you name it, the IoT can be applied anywhere and everywhere. So you need to identify the there are already many applications like agriculture, pharmaceuticals, everywhere IoT networks have been established. So you can take the IoT wherever you require to capture the data, where there is a need for the data sensing. The IoT is the first network that comes to your mind is the IoT. Now, there are multiple parameters or issue in which you can start working on in the IoT. So, if you are looking for a research topic for yourself or for your students, then there's no need to work in all the domains, because that will be the wastage of time and the energy. So, I will advise you that identify few selected topics or domains on which you would like to work on, depending on what are the parameters of the issues that connects you. So one is the weight of the device. That's one of the proper big parameter. The device should not be bulky. It should not be heavy. So because you are establishing a real-time network, so you need to take a small-sized miniature kind of a device. Then what is the internal storage of the node? Should not be very low, should not be very, very high. So somewhere that balance has to come. What's the right amount of the memory of that particular node? Then what is the free buffer space available where I can store fresh amount of the data being captured by the node. So if the node is sensing the data, it need to store that data. So what is the free buffer space available for me? Now then what is a CPU? What is the processing power of that particular node, which I'm setting up in a network? So what is the CPU cycles? How many number of fetch, decode, execute, and write back cycle it will work out. So CPU processing power should not be low. Otherwise, you won't the node will not be able to capture the data at phenomenally high speed. Then what is the kind of the network in which I'm establishing? Is it the IoT, or I'm deviating and establishing an ad hoc network, or I'm establishing a Bluetooth network, or establishing the metropolitan area network, or I'm setting a body area network, or I'm setting a delay tolerant network. What is the kind of network I'm actually using for my node? So that network has to be clarified from my side, because there are many kind of the wireless network available today. Then what is the energy efficiency of that particular node in a network? So energy efficiency is a very good parameter. So if you're looking for a track of working in IoT, you can start working only for optimization of the node's energy, the battery power of the node. In the minimum consumption, you should be able to get the maximum returns. Then what is the mobility pattern of the node? Is the node static or the node moving? At what pace or rate the node is moving in a network? So mobility patterns should be, are they random? Are they static? In random, what kind of mobility pattern in random also? Random waypoint mobility model, or maybe a city urban model or a rural model? Is what kind of mobility patterns on the node has? Then what are the congestion within the nodes of the network? Because there are so many nodes in the network, they might start relaying the data to the local data centers or over the cloud to the remote centers. So due to the so many congestion, because as the traffic density of the nodes is very, very high, it can result the congestion in a network. So I have to optimize it. This also have to reduce. I cannot eliminate the congestion. I can always cut it down. I can always start working. I can start using the algorithms that can minimize the congestion of the data packets in the network. Then I can also start working on the routing of messages in the network. And I will be giving a demo to you as a part of this session, wherein I can communicate between the nodes in the network. I can transmit the messages from one node to another node in a network. So routing is also perfectly possible within the network. So multiple number of the nodes, they will all start communicating with each other, and the messages will start flowing from one node to another node. So routing is a very important track, a good track in the area of the networking, in the area of the IoT. And for doing the routing, IoT uses two kind of the routing protocol. One is the MQTT, called Message Queuing Telemetry Transport, and the other is the COAP. COAP stands for Constraint Application Protocol. So MQTT and COAP, Message Queuing Telemetry Transport, and the Constraint Application Protocol, the COAP. Sensors we have already discussed, so there is no point to rediscuss it again. The importance of sensor in the case of the IoT. Without sensor, IoT doesn't work. So sensor are the brain behind the entire nodes in the IoT network as such. You have a good quality sensors, you will be able to capture the high quality of the data. You have a poor quality sensors, just a minute. You have a good quality sensors, you will be able to capture high quality data. You have a low quality or a poorly configured sensors, you will have a poor quality data, not the good quality data as such. Now, research papers, we will discuss few of them after the simulation part. That's a promise from my side, discussing on the usage and applicable of the IoT in the 5G and 6G networks. Now, when we talk of the routing, the name of the two person who have done a very good job in the case of the IoT comes to mind. First is the Dr. Andy Stanford Clark for the IBM and the Erlen Nipper of the ARCOM. There are two persons who have done a lot of good work in the area of the routing of messages in the IoT. That has been their primary area. How to efficiently carry out the routing of messages in the IoT network. They have done a lot of good quality work and almost dating back 20 years back then when they started the first version of efficiently routing of messages in the IoT network. And they were just like Kevin Ashton, they were also shortlisted for the ACM Turing Award, but they also never got it. But their work is being still referred today. Their work is still being useful today, and the many number of the students who have successfully did their PhD also in this particular domain only. How to do optimize routing of messages in the IoT network by using the MQTT and COAP protocol. Now, for doing the routing of messages in the IoT, we have a model called publisher subscriber model. It's called pub subs model, publisher subscriber model. Now let's see how does it operate, how does it work. Initially, we'll have a server. So we'll have a single centralized server. Now this server can have one broker or multiple number of broker inside it. So you have a server and within the server you have a broker. Now in my diagram, theoretical diagram, I am showing only one broker within the server. But in the real time, a server can have more than one broker inside it. So there's no upper limit part of it. Now what will the broker do? Broker will work on behalf of server and contact with multiple number of clients. So these clients are called as publisher and the subscriber. So on the left hand side, I've got another software process running on my machine called as a publisher. A publisher is one who captures the data. For example, in the which I took of the Thar desert of Rajasthan in a Jaisalmer district, I will have a publisher. What will the publisher do? It will capture the data, right? Because publisher means you are producing a fresh data. So you're capturing a new data as such. And then you relay it to the broker of the server. What will the broker of server do? On the right hand side, we can see a table having two columns. Now, this is a small table I have shown here, but in the real time, the size of the table will be very, very high, running into gigabytes and terabytes. And I have shown only two columns, but in the real time, I can have multiple number of more columns inside it. So we have our topics. The first column is the topics, the temperature and the pressure. And the second column is about of the values. So for every field, we have got a corresponding value inside it. So temperature, the value is 30, pressure, the value is 25. So multiple number of the topics will have multiple number of the values inside it. And what are the topic? Topics are the multiple fields like atmospheric temperature, pressure, humidity, soil condition, seismic vibration. What are the field? And for that field, what is the value that has been captured? So here, publisher is telling to the broker. Now I will have another column called date. That on 1st January, I can have another column time. At 9 a.m. in the morning, the temperature was 30 degrees Celsius. So I can create more columns inside it. These are just a sample table having two columns are topics and values. Topic represent multiple number of fields and values are the integer values which will be corresponding to those particular fields. So I can have more columns inside it. I can have a date, time, month, year, latitude and the longitude coordinates of the node where exactly it is located. So I can have more column and I can show more information inside the table. Now, for whom this information is meant for? So here I comes the consumer, and the consumer we called as subscriber within this publisher subscriber model or the pub subs model. So again, a broker can be linked to one subscriber or many number of subscriber inside it. So theoretically, there is no upper limit on the number of subscriber that can be connected to a broker. A broker will pass on the information which it has received from the producer to the subscriber, and it can be the freeway model. The broker may not charge anything, or it could be a paid model where for every record you charge something from the customer, from the subscriber, and then accordingly you make a payment. So I can have a payment model here, or I can have an auction model where the resources can be auctioned off by the broker, and accordingly he will charge the money from the publisher or from the subscriber. To understand the example, let's take an example of a property dealer. And now, a property dealer sits in a colony. Normally operates in a residential area. Now, he will maintain a register. The register will have two sets of information. First is who are the landlords or the owners whose flat is ready for renting for who are looking out for tenants. Because let's say they have got 1 BHK bedroom hall kitchen or 2 BHK 2 bedroom hall kitchen, and they want to rent it out to the suitable tenants. So what will the property dealer do? He will record the information about that particular house, where the house is located, how much amount of woodwork has been done, what is the floor of the house, the granite or marble, what is the amount of the number of electronic appliances available in that particular flat. So we will record on all the information of that particular resource of that particular property, and then he will share that same information with the multiple number of tenants or the person who are looking out the house for rent. They will approach. So let's say if the person approaches, he says my budget is still 10,000 rupees and I want a 1 BHK flat in it. So what will the server or broker do? Broker will share the information about all those properties who are 1 BHK and whose value is within the, let's say, 10,000 or 20,000 of the budget of the customer. It's easier to say that. So those information will share to him. So owner or the landlord of that particular property is called a publisher here, because he is the owner, he is producing the resource, and the information about the resource is being shared with a particular subscriber. What are subscriber here? The prospective tenants or the prospective person who are on the lookout for the rent for the particular flat. So the broker will set up a deal between the owner of the flat and the tenant of that particular flat, and he will charge commission 50% from either side. So let's say if the broker is arranging the property for 30,000 per month, so for the first month he will charge 15,000 from the landlord or the owner of the property, and 50% of the source from the tenant of the property as brokerage, because he has brokered the deal, he has set up a deal, and then he walks away with the profit from both the parties. Now, the same line has been told or worked out in the case of the IoT, where we'll have a good quality publisher subscriber model, and that model will be able to manage the resources between the client and the server, or between the publisher and the subscriber, and the seamless sharing of the resources can take place. Now, let's see the demo part of it, how it will work out if I want to actually execute the program of doing a routing of the messages. Are we able to see this browser window where it says download org.eclipse?
Yes, sir. It is visible, sir.
Fine. Thank you so much. So there are some of the resources I need to download on my machine. Like first is I download the PAHO client of the Eclipse network. So that's I need to download it. And the other thing I need to download is the mosquito protocol, like mosquito.2.0.20.tar.eclipse. GZ. So it's Eclipse Foundation and the Mosquito. Now the protocol which we are using in the IoT is MQTT, Message Queuing Telemetry Transport. Now since the name is very similar to Mosquito, so we have call it as a Mosquito, MOSQUITTO. So MQTT and Mosquito, if you spell them out, they sound the similar Mosquito name only. So we have a protocol by the name of the Mosquito protocol. So MQTT is widely called as a Mosquito protocol only. So I need to download for the Windows. The installer is already available here. I need to download and configure it. Now let's come to the program. Yeah. Now this is a protocol. This is a program coded in Java programming language for carrying out a communication between the publisher and broker. That is what the objective is. So if you see this diagram here, what I'm focusing on is carrying out a communication between these two parts, the publisher and broker. Then we can carry out a communication between the broker and the subscriber. So let us see the first part, the publisher and the broker, how to do carry out a communication. So in the line number 1 to 5, what I do here, I import multiple number of the classes belonging to the org.eclipse.paho.client. Now, Paho client is a client produced by the Eclipse Foundation exclusively for carrying out the routing of messages in the IoT network. So I import them. And which version of the protocol I'm using? Mosquito version 3 protocol. So MQTT version 3. That's the latest one. Though we have got a multiple iterations of 3 also, even 4 is in the market nowadays. But 3 has been working fine. And we have got a multiple number of the predefined classes of the Mosquito package. So MQTT connection options, MQTT exceptions, MQTT message. So what I do here, I import all these corresponding classes within my network so that I can start using it. Then what I do, I define a class called Mosquito publish sample one. Now this is the name of the class which I define. So the code has been done in Java. So even if you have done Java, it's good. If you even if you have not done, don't worry. I will go through the code slowly so that you can understand the code. So here we define a class publicly available so that all the other classes can access the member function, member variable of this particular class. Then I define the main function. I say public static void main string args. That's the way we define the main function within the Java. The public, we all know, since I want to make my class publicly available, accessible to everyone, I'm defining the main function as public. Now, in this particular case, why I'm doing it? So that the Java virtual machine who will execute the program is able to make a call to this main function. If I define it as a private, then declaration is okay. But the function cannot be called by Java virtual machine because now this function becomes has a local scope within the class called Mosquito publish sample one. So it is essential that the main function should be declared as public in nature, right? Then, if you are familiar with object-oriented programming, we need to instantiate the class so that we can get the object of a class. Just like what C++ does. You define a class, then outside the class definition, we have got a main function. Within the main function, you instantiate the class, and then with the help of the instance of that particular class, the object or the object of that class, you make a call to the member variable and the member function of that class. But in the case of Java, the main function has been encapsulated within the class. That means main function is not being defined outside the class. It is within the boundaries of the class. Now, if the main function is within the domain of the class, then how will the Java virtual machine call it? Because I have not instantiated the class. So for this reason, the main function is declared as static in nature. That means making the function independent of the object of a class. Getting a point? So that's why I'm declaring the main function static in nature so that the Java virtual machine can directly make a call to the main function without any problem. Then we have got a void, which is the return type, then the name of the function. Then by default, everything you receive in Java is of the string type. So what I do here, I create an array called string, and then I receive the argument as a runtime. So string, square bracket, and the args. Then I come to the content of the program. What I do here, I declare a topic variable, and it's been called mosquito example, the very first program. So I just declared as the mosquito example. Then I define the content. That content is a what is the content the producer or the publisher wants to publish onto the broker. So I say message from the mosquito publish sample. That's any string, any message. You can write any message of your choice. Now, IoT defines the quality of service parameter that play a very important role, especially in 5G and 6G also. The quality of service should be very high as possible. So the three quality of parameter defined in the IoT, the level 0, level 1, and the level 2. Three kind of the quality of service defined. Now for the 5G and 6G network, we always go for the quality of service as 2, the best quality as such. Then what is a broker? So on which IP address the broker is going to work on? Now since it is going to work on my machine on the local host, I say 127.0.0.1. Then on what port number the broker is going to receive the request from that particular publisher or the producer. So it says port number 1885. Now, if you look at the IoT, in the IoT, all the during the routing of the messages in IoT, the mosquito protocol always receives the request on the port number starting from 188. So 188X. So 1881, 1882, 1883, 1884, 1885, 1886, and so on. Then I come to the client ID. What is the client ID? I initialize with a string called Java sample. I can take it any parameter, no problem. Then I make a call to the one argument constructor of the memory persistence class. Why I am doing it? Because when the message will flow, I do not want any data loss to take place. So I invoke a persistence property of a Java, wherein I will make sure that the data is persisted properly. It is doesn't get corrupted or doesn't get lost during the process of transmission from the publisher to the broker. Then I come to the next line of code, the try part. Now Java says you should do a proper exception handling because at the runtime there could be a situation where your code may fall flat, the code may break down. So it's always essential that I properly do the exception handling and handle my program. So I come to line number 19 and I make a call to three argument constructor of the Mosquito client class. So I will have a client class, I will have a broker class, and I need to establish the connection between them. Now here are three parameters are being passed. One is a broker, one is a client ID, and one is I am passing the persistence, the the variable which I have created here, the object of a memory persistence class that is being passed as a parameter here. Then I make a call to the line number 20. I make a call to the no argument constructor of the mosquito connection options class. Why I am want a connection option? Because I need to clean the buffer. I need to clean the streams which are carrying the data from one IoT network node to another IoT network node. So I make a call to the set clean session function. Now this function belongs to a class called mosquito connection options. So in the line number 20, I have instantiated the class that gave me this reference variable. And then with the help of this reference variable, we make a call to the set clean session function, passing the parameter as true. It is very similar to just like in C, we write the line f flush stdin. So that means you're flushing off, you're cleaning off the stream through which the data will communicate or move. Then the line number 22, I make a write a line of code that says from the publisher, I'm trying to connect to a broker. So I just write the statement connecting to a broker. Then whatever connection options were already set up, I activate them. So with the current client. Now where is the current client? The sample client. So I say sample client dot connect and the connection options that I set that particular line. If I'm able to reach to line number 24, I will say system order println. Means that means the publisher has got connected to that broker. Client has got connected to a broker. Now the publisher want to publish the message. So what message trying to publish, which have already been initialized in the variable called content, right at the line number 12. That is message from the mosquito published sample. That is a message the publisher is trying to publish onto the broker. So it just displays the same message, publishing message and the content. Then we got the line number 26. Now what the line number 26 says, make a call to the one argument constructor of the mosquito message class. And within that, what I'm doing, I'm fetching the bytes from the content because in Java, everything is a Unicode type. That means it deals with 16 bits of the type. But in the case of the C programming, everything is dealt in terms of bytes. So since my basic function is being written in the C language, so I make a call to the get bytes function and I extract the bytes from that particular string. And then I make a call to the set quality of service parameter, passing the value of the quality of service, which is the value 2 here. Then I publish the function. I make a call to the publish function over the publisher. So sample client is the name of my publisher. So I say publisher dot publish function. And what to publish? The message corresponding to that particular topic. So topic, comma, the message. So what is the topic here? Which has already been decided before advance. So topic is by mosquito examples. And what is the message here? Message is a corresponding bytes which have been fetched from the string. And what was the string here? The value of the content variable. That was message from the mosquito published sample. Right? Now that has been set as the quality of service parameter. Then the line number 28, we make a call to the publish function with a corresponding value of message and the topic attached to it. If I'm able to reach to this line, I say message has been published by the publisher onto the broker window. And the line number 30, I disconnect. I disconnect completely after publishing the message onto the broker window. So publisher connected to the broker, published the message to the broker, and then it got disconnected from the broker. So once I'm able to reach the line, I say, now you get disconnected. And then I exit out from that particular program. Now, if for any of the reason the program collapses or breaks down, so immediately we are doing the exception handling part. So I'm making instantiating a mosquito exception reference variable called ME. So what could be the reason code? What could be the message? The localized message if you want to print the real cause of the program failure, everything will get printed here. So this is a program written in Java programming language, which uses the Mosquito protocol for what purpose? For publishing the message from the publisher to the broker. That's the first part of the program. Second part of the program talks about printing the message from the broker to the subscriber. That is what we are doing. Forwarding or the routing of message in the IoT network using the publisher subscriber model. Now, having discussed the program, now let's see the execution part of it. How do I do that? So what do? I open a command prompt window and I start the Mosquito server inside it. So since I've already shared it, I've already downloaded it. I will also share the same thing with you all on the command prompt window so that you can also open the same thing on your machine and you can have access over the resources. So I've shared the link from where you can download that particular resources. So one is a Mosquito download and the other is a Java example download. Both of them are being here shown here. So now we come back to our, we open the command prompt window. So let me increase the size. So what do I do? I start the Mosquito server. Now, if you look at the before that, what I did, rather, let me clean it off so that I can show it in a better way. Yeah. I downloaded the Mosquito from the net, from the resources which I just shared. And at the command prompt window, I'm setting the path telling to the environment that you reach to the Mosquito protocol. So where is the Mosquito located? I go to the C, program files, and within it, the Mosquito, which I have just shown. Yeah, this is the Mosquito. So I'm trying to access this folder. I'm trying to access these resources from the command prompt. So this is a real Mosquito server, which will help me to do a routing of messages from the source to the destination. So I'm setting a connection or a link to this particular folder from the command prompt window. So set path is equal to C drive, program files, Mosquito, and percentage path percent. So that all the previous locations of the path variables are maintained, they are remain intact, and they don't get disturbed, right? Now, since it has got successfully established, what I do next, I start the Mosquito server. So I say mosquito.exe hyphen v. V is a verbose mode. That means whatever it will do, will keep on printing onto your machine. And P is a port number on which it is printing. So I say 1885 is a port number on which it prints that particular uh, working of it, the log file. Now, once you have started, you can see here it prints certain things on the server log window. One is a Mosquito version 2.0.18 is starting using the default configuration, starting in a local mode only. They're starting on my machine only. Then creating a configuration file. Then it tells the resources from where it is downloading it from the mosquito.organization.documentation authentication methods. Then this is able to handle both the kind of the networks, the IPv4 network as well as IPv6 network. And then the cursor start blinking. Cursor start blinking means the server is now running. It is ready to receive the request from the publisher. So I have started the broker and now the broker currently in the working state. Now any publisher can connect to it and then can publish the content onto the broker. Now what I do, I open another command prompt window. Yeah. So in the background, the server is running. And in the foreground, I start another program here, the Java program, which I just showed to you. And I compile that particular program. So I say Java C. Java C is the name of the compiler, Java compiler. Mosquito publish sample1.java. Now, what is Mosquito publish sample1.java? It is the name of the same program which we just discussed. The Mosquito publish sample1.java. So, what I do here, I compile the program. That's the way Java tells us. So, you just press enter. It will compile the program. And if there are no bugs or error, that means the .class file of the program is ready for execution. So now I can launch the Java virtual machine and then I can write the entire name of the program. Just I don't need to type the file name extension because when you execute a program, you don't write Java, .java. It is assumed that the .class file will get automatically launched. Now, since the .class file is ready, I can directly launch it for the user. Now I can see here, program has got successfully executed. First line says connecting to broker TCP 127.0.0.1 colon 1855. That means what line has got printed? Now, if you look at this program, everything will get printed in the same manner. First, this system.println will get printed connecting to broker. then the connected will get printed, then publishing message will get printed, then publishing message public will display, and then disconnected. Everything wherever system.out.println has been written, all those lines will get sequentially printed in the program. Something like here, connected to broker, connected, publishing from message, message from mosquito publish sample, message publish, and then finally disconnected. And then again the cursor start blinking. So it is again ready to receive more requests from the publisher. So this is a window of the publisher. Now, if you go to the broker window, yeah, you can see here so many number of lines have written. Earlier only, what was the last line available here? Mosquito version 2.0.18 running. Now it says new connection has been received from 127.0.0.1. Now this is a my machine, local machine. So I'm giving the IP address of local host. In the real time, it would be, let's say, 10.6.4.10. So that was the IP address. And then port number is 1885. Then it says sending connection acknowledgement to Java sample. Receive the published message from Java sample. And then what is the amount of data which has been sent? 30 bytes. Sending publisher record to Java sample. Receive publisher record from Java sample. Then sending publisher, then finally receive disconnect. So everything what has been done in the program, it displays the same thing onto the command prompt into the log file of the Mosquito server. Any doubt, any query regarding this program and its execution? I will share the source code of the program. So if you want to execute it, please go ahead and do it. I will just copy the entire program and share it onto the, if you want to execute, maybe if I am not sure how much amount of energy you have left after the entire day of working, but if you want to execute the program, I will be happy to share them. So I've shared the entire program onto the command prompt window. You can pick up the program from there. Also, I will email the program to the coordinator also. So you can also share in your WhatsApp group if it has been built. So you can properly download the program, compile it, and then execute it in your system as such. Any doubt, any query regarding it? Okay, good. Now, few more things which we can discuss. The usage of the IoT when we talk of. Now, there's a very good paper which I found on the web which I wanted to share regarding the integration of the IoT in the 6G. So we say towards 6G Internet of Things, recent advances, use cases, and open challenges. It's a very good paper. That is what I was discussing. Internet of Everything (IoE) or IOX. Now, if you, there's a very good diagram here. If you look at the integration of the IoT in the network, today IoT in 6G core network supports everything. Like the big data analytics part is there, 3D printing part, Industry 4.0 standards, Industry 5.0 standard, Industry 6.0 standards, the blockchain, the UAV, the unmanned aerial vehicles, the security part. Say now, security is a big domain. If I want to work only in exclusive security part, then there are multiple tracks. Like I can work on steganography, I can work on cryptography, using both the technique of symmetric and asymmetric cryptography, using technique like Caesar cipher, Railfen cipher, affine cipher, Veneer cipher, or I can work on algorithms like DES, data encryption standard, AES, advanced encryption standard, RSA, Rivest-Shammir algorithm. So the full world of the cryptography only, which you can work on while working on the integrating 6G core networks. Because a lot of security stuff is required while working on the high-speed networks. So you have to remember the security principles. Then I can also use the hashing algorithms like the MD5, the message digest 5 hashing algorithm, or the SHA algorithm, secure hash algorithm, or the Whirlpool algorithm. So multiple kind of the hashing algorithms available which I can use it. I can work on ubiquitous computing part. I can work on the robotics. I can work on artificial intelligence, utilizing the supervised and non-supervised machine learning algorithms, which are nowadays being a tremendous amount of work has been done. For example, you can go to the Kaggle or any other repository and download the IoT data sets, or you can go to the Google Play Store or Google Collaborate. A lot of number of IoT data sets are available. You can download few of them and then integrate them with your network. point I'm trying to say is, let's say if I want to do a simulation in cup carbon simulator for the IoT. So you can go to the site called cupcarbon.com, cup carbon twin IoT 6. It's a very good simulator, especially if you know the Java programming language. So you can download the Cup Carbon 6. I will share the URL in the chat window. You can pick up from there so that it becomes useful to you. So it's a very free of cost open source simulator. You don't have to pay anything to anybody. So it's a free and open source simulator. Only thing is that you require a Java, good working knowledge of the Java programming language. So you can download it from the web free of cost. Start with the Cup Carbon 6 digital twin or the IoT programming. It integrates everything ESP32 microcontroller. I can do a Node.js programming with it. I can do Julia programming with it. There are multiple tutorials also available. You can download the tutorials from the web. You can go through them at your own pace whenever you get the time. And then you can plan the simulation uh, of the IoT nodes using the Mosquito protocol or using a Python programming if you want to integrate, or using a Sanskrit programming, or using the Mosquito protocol programming, or using the ESP32 microcontroller programming using the Raspberry. It's all free, so you don't have to pay anything to anybody. So there's a very good presentation here. You can run that, and again, I will not be executing everything here because you can all download it from your end. So it's a very good simulator available on the net. The Cup Carbon simulator, you can download it and execute it. Another good simulator which you can download and plan your simulation all free of cost. You don't need to pay anything to anybody. It's called Contiki Kuja. So you can go to the GitHub repository of it. So this page contains the information about the Kuja network simulator for Contiki. Now here it talks about what are the various features, what are the added features which you can use for carrying out a simulation. Now what are the steps to be followed? What are the mode types to be created? Everything that they've already discussed about this part. So you can plan your simulation and try to do it within the IoT network scenario without any problem. And it works perfectly fine. So there's no any problem of working with the Contiki Kuja simulator. Only thing is that you should be a bit familiar with the working of the open source because we don't have a good working version of the Kuja simulator for Windows, but we have got a good working good working environment for the Linux is perfectly available. So you can plan your approach. Let me give you a quick demo if the time permits us, and if we have a time, yeah. So what I'm doing here, if I want to run a IoT simulation in Contiki Kuja simulator. So what I do here, I download the Oracle VM VirtualBox Manager. Now, what is this VirtualBox Manager? We do not have a Windows version of the Contiki Kuja simulator. So what do? I download the Oracle Virtual Machine Box Manager, which will act as an interface between the Windows operating system and the Contiki Kuja simulator. So I set up my yeah, I create my own tool first. So I click on the new part. Let me close it down because it has started working. I want to give the demo from the scratch so that you can actually do it at your own end. Let me close it down the window. Is the Oracle Virtual Machine VirtualBox Manager visible to all? Anyone can say yes or no.
Yes, sir. It is visible, sir.
So what I do here, I click on the ad and I create my, wait a minute. I click on the new, yes. And I create one, let's say I say, if I am, hopefully I am writing the right name, Kogu Nadu, should not be the spelling mistake. Then what do I do? I give a image, then type is, let's say, the Linux operating system, virtual machine box is a Linux. I give the base memory. It says create a virtual hard disk, use existing hard disk virtual drive. So I need to go and attach it. So I give the name of the file. I click on the next and then it gives me a summary type and then I say finish. So that means I have created one of the tools which can be used for starting a simulation, a good amount of simulation, wherein I can work on the Contiki Kuja simulator using the particular uh, uh, programming language is all Java. So I cannot say any other language you can work on. You will have to work exclusively on the Java part only. So you can if you can see here, it's good. Though since the time is very short, I will not like to extend it beyond because that simulation will itself take maybe 20-25 minutes more. So the session might go till 9:30. So since it is already late, so I will not like to go beyond that. But I will share a link wherein you can go to the. Uh, I will just share the video of it, so that will be handy to you. Just a moment. So let me. So this is my YouTube channel where I've hosted large number of the videos. So if you're ever interested, so I'm just sharing a link of it onto your chat window where I've hosted number of the videos where I've shown the simulation for the benefit of the students. So I will just share the link of the video which I have shown for the Kontiki Puja. So if you ever feel interested in doing that, you can browse through it. uh, that will be handy to you to start working on it, and you can only if you enjoy working on it, because uh, Contiki Puja simulator is good only if you are comfortable or familiar with the. So this is all about the Contiki Puja part. So you can go through it, and I've given the complete demonstration how to work on that Contiki Puja simulator. And also there are multiple number of other research paper which I found, which I wanted to discuss in a more length, but the time is not permitting. So, like the impact of 6G IoT technologies on the development of the agriculture. And this paper is also relevant because it's a good paper. Just a paper published in 2023 where it's a good quality paper. I will share the paper again to the coordinator so then you can share in your group, where how we can deploy or how we can exploit the benefits of 6G IoT network in the domain of the agriculture. Another good paper which I found, which I wanted to discuss at length, was how to define going for a 6G IoT network, a perspective on resource optimization strategies, challenges, and future directions. So again, this is a good quality paper by the IEEE Access, just a last year paper in 2024. You can see here, which talks in detail about the various optimization strategies working for the 6G IoT networks. So it's a good paper whenever, maybe during the FDP or after the FDP, when you get the time, you can go through the paper that talks at length about the benefits and the reliability and the performance and the security part of the 6G IoT networks. So with that, I would like to conclude. I will be happy to answer any query from your side. Please feel free to unmute yourself and ask. Any queries from the audience?
Yes, sir.
Yeah,
Sir,
please.
what are yes, sir. So what are the protocols available in quantity puja simulator?
Ma'am, Kuja Simulator uses the MQTT protocol and COAP protocol. Actually, in Kuja Simulator, you have to do a lot of C programming. So there are
Okay.
large amount of the code, C pro code available there. You can customize the code. You can change the code, and then you can
Okay.
write your own code for both for MQTT protocol as well as for the COAP protocol.
Okay. Okay. Okay.
Because C programming, we all know we can write our own code. So basic skeletal code has been provided to us, and then we can build on the more code on it.
Okay, sir.
So I'm just sharing my mail ID. If there's any doubt regarding whatever I discussed and taught, please you can feel free to drop me a mail. I will be happy to interact with you. So Rahul at the rate ipu.ac.in. And thank you all so much for listening to it and being such a good audience. Thank you. Thank you from my side.
Thank you, sir. Thanks for sharing your valuable knowledge.
Pleasure. Pleasure is all mine.
Thank you, sir.
Okay, I take a leave then.
Okay, sir.
Okay.
Participants are asked to fill the feedback form as soon as possible because the link is only valid for a few minutes. I repeat again, participants are asked to fill the feedback form as soon as possible because the link is only valid for a few minutes.